first time. So this is lesson 118, logarithmic equations. So the rules for logarithms are that if logarithms with the same base are added, then the arguments are multiplied. So on this side we have the expanded form, and on this side we have the condensed form. And so what we do is, when we condense them, is we multiply whatever is in the argument. So 5 times 7 is 35, and this condenses it to 1 log 10. Now you do have to have the same base all the way through in order to be able to condense the log and make it log base 10 of 35. So that's if you're adding, you're going to multiply. Now we have if logarithms with the same base are subtracted, then the arguments are divided. So again, we have log base 3, log base 3, log base 3. So when we condense this into 1, we're going to divide 14 by 7, and we get log base 3 of 2. The order matters when you're subtracting. So if we did it this way, when we condensed it into 1 log, it would be log base 3 of 1/2, because 7 divided by 14 is 1/2. The last rule is that if logarithms are multiplied by a constant or a variable, then the argument is raised to that power. So what we can do is move this number in front to the exponent. So we moved it here. Or if it's a variable, we move it here so it goes in the exponent. So we're going to apply all these rules when we solve. So to put this in your reference guide in the back, and this is going the other direction. So we have the condensed form first, and we can separate this into log bm, and since we're multiplying, plus log bn. So again, we call this the condensed form, and this side is going to be called the expanded form. And you want to be able to go back and forth as needed. So for this one, we have log base b of m divided by n. So when we expand it, the divide changes to a minus, like that. And then the last one, the rule we learned, was with any exponent. So again, this is the condensed version. When we expand it, we put the n, or whatever is in the exponent, in front. Alright, so let's actually solve an equation. Oh wait, first one more thing. If the bases are the same, then the logs are equal, and the logs are equal, then the arguments are equal. So as long as you have it all condensed on one side and condensed on the other side, then you can drop the logs off and you can say that the arguments are equal. So that's how you get rid of the logs, but you have to have log of the same base on both sides. So log base 7 in this case, and log base 7. Okay, so on the left-hand side here, we first need to condense the log. So we have a plus sign in the middle. So what are we going to do with the arguments? When we condense it into 1, we are going to multiply. So the log base 5 just stays. Now it's in 1 log base 5. And we would multiply the 4 by the x plus 8. And we'll distribute in a minute. The other side we've already condensed. So you have to show this step, all right? You must show this if you want full credit. Okay, then the next step is now we have the same log base 5s on both sides, so we can just set the arguments equal to each other. And I went ahead and distributed that. Okay, now subtract 32 from both sides and divide by 4, and we get an argument of 12. You do have to check your answer. You have to always have a positive argument. So if you plug in 12 here, you get a positive 20, so you're good to go. You can just never have a negative argument, but this solution works because it gives us a positive argument. All right, same thing here. We're going to condense this into 1 log 7 on this side of the equation. But this time we have a minus sign. So what are we going to do with our arguments? We are going to divide. Okay, once you've condensed it so there's just 1 log 7 on each side, now you can set the arguments equal to each other. So we can drop the logs off. Now I want to solve. I'm going to put this over 1, and I'm just going to cross multiply. So x plus 7 times 1 is x plus 7. And we're going to multiply this by 10. Be sure you multiply the whole thing by 10. So it's 10x minus 20. Okay, I'm going to move this x over, subtract 1x from both sides. I'm going to add 20 to both sides. And I'm going to divide both sides by 9. And we get our solution of 3. Again, check and make sure you get all positive arguments. So if I plug in a 3, we get positive 10s, that's good. We plug in a 3 here, we get a 1, that's good, all positive. Okay, and the last property that we haven't used yet is to move this 2, if there's a number in front, to the exponent. So we have to condense it by making this x squared. Now that we're condensed and we have log 3 on both sides, we can set the arguments equal to each other. And what do you have to remember when you take the square root of both sides? Plus and minus. Okay, but let's go and check both solutions. If we plug in a negative 4 here, that gives us a negative argument. So you cannot have negative 4 as a solution. So the only solution that works is positive 4 because it gives you a positive argument. You want to try these on your own, see how you do, and hopefully that cleared some things up for you.